You know what? Let's start from the reactivity instead of electrolysis. So let's start with reactivity. Today we'll do reactivity and then we'll do electrolysis. So reactivity is how reactive an element is. If an element is more reactive, for example, uh, sodium Na is more reactive than zinc. So if I had sodium reacting with zinc sulfate, then sodium can displace zinc in zinc sulfate. So when I have this reaction, then sodium sulfate would be produced because sodium is more reactive than zinc. So again, if something is more reactive, then it can displace the less reactive element. So what is the reactivity series? The reactivity series starts with P, S, C, M, A, C, Z, I, and H, C, H, C, S, and G. So what is this? P stands for potassium, and S stands for sodium, C stands for calcium, M stands for magnesium, A stands for aluminium, C stands for carbon, and then this is zinc, this is iron, this is hydrogen, then this C is copper, S is silver, and finally G here is gold. So this is the reactivity series. And what does the reactivity series say? That going down this reactivity series, my reactivity would decrease. So potassium is the most reactive, whereas gold is the least reactive. So memorize this reactivity series. And what does this reactivity series tell you? That if I had, for example, if I had calcium and reacting with magnesium sulfate, MgSO4, then what will this reaction happen or no? If my calcium is more reactive than my magnesium, then yes, this reaction will take place. But if calcium is less reactive than magnesium, then this reaction cannot take place. But I can see my calcium is higher than magnesium. So calcium is more reactive. So this reaction will take place. Calcium will displace magnesium and you'll get calcium sulfate. So this is how they'll ask you questions. Uh, so yeah, and there is you also need to know halogen reactivity. What this is that down the group, meaning fluorine, chlorine, bromine, and iodine, going down, the reactivity decreases. So my fluorine is most reactive. Fluorine is most reactive and iodine is the least reactive. So do we have to memorize this? Because every resource had more or less other elements. This is the elements that you learned in IGCSE. So I'm following the IGCSE and A-level syllabus. Yes, this is the type of list that you have to memorize, as well as the halogen reactivity. So yeah, this there is an acronym for memorizing this. It gets easier. It's please send please send cats, monkeys, and cute zebras into hot countries. said Gordon. So yeah, I'll memorize this this way. You can do the same. So where was I? Yeah, fluorine is the most reactive. So if I had HCl reacting with fluorine, this is not a feasible reaction, but let's say that there was this reaction. Will this reaction happen or no? Yes, this will happen because my fluorine is more reactive than my chlorine. So fluorine can displace chlorine. So I get HF, hydrogen fluoride. So yeah, this is how they can ask you questions. And why am I explaining reactivity series to you? Because this reactivity series will come in handy when you're dealing with electrolysis. So let's move on to electrolysis now. In electrolysis, there are two types of, there are something called the nodes, electrodes, sorry, electrodes. What are the electrodes? There are two types, the anode and the cathode. At the anode, anodes, remember, are positively charged. Cathodes are negatively charged. So if I had a solution that had the anode, this is the anode, and this is the cathode. And if I had negative ions and positive ions, the positive ions will get attracted to the cathode, and the negative ions will get attracted to the anode. And remember that if I have a solution, then the solution will always contain OH minus ions and H plus ions. So in a solution, I'll have these two ions regardless of what's present in my solution. So there are two types of liquids that you'll find in electrolysis, the solution and molten state. In molten state, you do not have OH minus and H plus ions. So molten doesn't have H plus and OH minus ions. This is not present in molten state. So, and how do you figure out what will come at the anode and what will move to the cathode? At the anode, remember, you will have the anode is positively charged. So negative ions, meaning either non-metals, non-metal ions, because non-metal ions, remember, they will form uh, negative ions. So negative ions, for example, uh, chlorine, iodine, bromine, chloride ion, bromide ion, and iodide ion. All of these are negative, so they will form at the positive ions because these negative charges will get attracted to the positive charges. And similarly, what else can form on the anode? If and only if the electrolysis has a solution, then my OH minus ions will move towards the anode because OH minus ions are negative. So the OH minus ions move to the anode. But what will form from this OH minus ion? Remember that from this OH minus ion, only the oxygen will be formed. Only the oxygen, the negatively charged oxygen, will be formed at the anode, not the complete OH minus ion. So two types of things, species that can form on the anode. One is the oxygen from the OH minus ion, and second, the halogens, the non-metal halogens. So at the anode, I can form either of these two. So either halogens or my oxygen. So how do I figure out if either of these will form? So remember that if I have a halogen ion, then that halogen will be formed at the anode. For example, let's say I have HCl, concentrated HCl. I have chloride ions, right? In this solution, right? Let's say that I have a solution of HCl, not concentrated. So here I'll have two types of ions. I'll have H plus ions. I'll have chloride ions from HCl. And then they tell me it's a solution. So I'll have OH minus ions as well as H plus ions. So what will form at my anode and what will form at my cathode? So I told you at the anode, if I have a halogen ion present, if I had a halide ion, then that halogen will be produced. For example, I have chloride minus ions. So at the anode, I'll have chlorine being produced. So, but if I didn't have chloride ions, let's say I had H2SO4, I had sulfuric acid instead of hydrochloric acid, then what will I form? If I had H2SO4, then and let's say this is a solution of H2SO4. So I'll have H plus ions from my hydrogen from my H2SO4 and SO4 2 minus ions, or SO4 minus, I forgot. But yeah, the point is SO4 is negatively charged, H plus ions are positively charged. This is from my H2SO4. Apart from that, I'll also have OH minus ions from my solution and H plus ions. So at the anode, do I have a halide ion present? I don't. So what will be formed? My oxygen will be formed at the anode. Oxygen will be formed at the anode. Even though this is negatively charged, but oxygen will be produced at the anode, because oxygen is negatively charged, and oxygen will be produced at the anode since I don't have any halide present. So I don't have any halide, so oxygen would be produced from the OH minus ion. Now, this was how anodes work. What about cathodes? So at the cathode, there are two types of examples. If I have a solution or if I have molten state. If I have a solution, then in that solution, I'll have the species from the, for example, let's take sodium chloride. Sodium chloride, NaCl. Yeah, I have a solution of NaCl. In this case, remember at cathode, what will be formed? Either H plus ions or the positively charged metal ions. And how do you figure out if H plus ions are formed or positively charged metal ions are formed? For this, you have to know that if this is the rule, that if a metal is less reactive than hydrogen, then that metal will be formed. That metal will be formed. So remember that if a metal is less reactive than hydrogen, that metal will be formed. So in this case, when I have a solution of NaCl, at the anode, I obviously know that at my anode, I'll have chlorine ions being produced because I have a halide ion. But at the cathode, I will either have Na plus ions from the NaCl, or I can have my H plus ions from the solution. So how do I know which will be formed? So for this, I go back and look at my reactivity series. I can see sodium is way up in the reactivity series, and hydrogen is right here. So sodium is more reactive than hydrogen. So in this case, sodium will not be formed. So I told you, if a metal is less reactive than hydrogen, then that metal will be formed. But since my sodium is more reactive than hydrogen, then hydrogen ions will be formed. So again, at the cathode, I'll have H plus ions being formed. So this was the case when I had a solution of NaCl. But what if I had NaCl in molten state? In that case, I'll have chloride ions at the anode. So chloride ions at the anode will produce chlorine, and at the cathode, you'll have sodium ions being produced, regardless of H plus ions. If it's in the molten state, then you can directly go and say that my metal ion will be produced, because in a molten state, you don't have H plus and OH minus ions. from the water, because solution, remember, solution contains water ions. It will contain water molecules, and water molecules have H plus and OH minus ions. So again, if you have a molten state, you can directly look at the species and then say that this will be formed. So the species will only be formed from this right here, not the H plus and OH minus ions. You only look at this and the reactivity series when you have a solution. So for example, let's do some examples. Let's say I have NaOH. I have a solution of NaOH. I have magnesium sulfate solution, and let's say I have molten NaBH. So in this, what will be formed at the anode and what will be formed at the cathode? At the anode, they tell me I don't have any halide ions. So at the anode, I'll have oxygen. Because I don't have any halide ions, so I'll always have oxygen. If I had halide ions, then the halide ions will be formed at the anode. So I don't have any halide ions, so oxygen is formed. At the cathode, sodium is more reactive than my H plus ions from the solution. So in this case, my H plus ions will be formed at the cathode, not the sodium ion. And similarly, if I look at a solution of magnesium sulfate, at the cathode, at the anode, I'll have oxygen, because I don't have any halogen or halide ion. And at the cathode, I'll have either magnesium or H plus ions. So how do I know what will be formed? I go back, look at my reactivity series. Where is it? Yeah, here. Magnesium is right here. It's above hydrogen. Hydrogen is right here. So magnesium is more reactive. Therefore, hydrogen would be produced. So where is it? Yeah, here. So in this case, when I have a magnesium sulfate, magnesium is more reactive than hydrogen. So hydrogen would be formed, because I want the less reactive species to be formed on my cathode. So moving on to molten NaBH. Again, at the anode, do I have, sorry, not NaBH, it's NaBr, my bad. Sodium bromide, NaBr. Yeah. So when I have molten NaBr, what would be formed at the anode? I have a halide ion present. So at the anode, my bromine would be formed, not my halide. The bromine atom would be formed. So Br2, not bromide ions. So at the cathode, what would be formed? Because they tell me it's molten, I will directly say sodium would be formed at the cathode. So this is how you figure out electrolysis. Now, moving on to something called half equations. So remember that anodes will always have oxidation, and cathodes will always have reduction. At the anode, you'll have loss of electrons. At the cathode, you'll have gain of electrons. So if I had Na plus ions being formed at the cathode, then for this case, my half equation for this would be Na plus an electron would give me sodium. This is one way I can write the half equation. There is another way of writing half equations. It's that sodium loses an electron and becomes sodium plus ion. Both of these are right. You can write any of these equations at the cathode. So sodium loses electron and forms a positive ion. So one thing that you have to make sure that is clear is that the charge, number one, is the charge must be balanced, and the species, number two, is the species must be balanced. So for example, I have one negative electron present right here, and I have one positive ion present right here. this right here is balanced. And I have this cancels out the charge. So I have no charge here at my right hand side, and at my left hand side, I have zero charge as well. Because on my reactant side, sodium is not charged. So I have zero charge here, and I have zero charge here as well, because negative positive cancels each other out. So my charges are balanced. Is my species balanced? I have one sodium on my left and one sodium at my right. So the species are also balanced. But and if I look at here, you can see that I have my electron, or my charges are balanced. I have positive and a negative electron. This cancels out the charge. And I have one species present on both sides. So my species and my charge is balanced as well. So for example, let's do oxygen at the anode. So oxygen, which is O2, would gain electrons. Oxygen gains electrons and becomes uh, oxygen minus ions, oxygen 2 minus ion. So in this case, uh, are my charges balanced or not? You can see I have 2 minus here. So I have -2 charge on my product side. On my reactant side, I have only one charge right here. So I have to write a 2 next to the electron to balance this. And similarly, I have, is my species balanced? It's not, because I have one oxygen here and two oxygen present right here. So if I write half right here, then my oxygen would become balanced and my electrons would also become balanced. So in this case, this is how you would balance oxygen equation. And this is my half equation for oxygen. So yeah. And so is there anything else? No, there isn't. So yeah, this is the reactivity series and electrolysis. And with this, we have finished the chemistry syllabus for the IMAT. And yeah, so hopefully you can start your past papers right now. So yeah, from tomorrow onwards, all of the chemistry classes will be taken for biology. So we'll have biology instead of chemistry. Yeah, so bye. See you in the next class. Everything is clear till now, right? Mm, yes, okay. That's great. Bye.